After using the 2-watt laser diode driver that I designed 6 months ago, I've been using it for the last couple of months and it's been working very nicely. Haven't had any issues at all with it. I decided to ramp things up a little bit and instead of the 2-watt laser diode go to a 40 or 50-watt laser diode. Using a device from Coherent. There's a 40-watt one and a 50-watt one, and they take 75 or 80 amps of current control to drive them. And decided to, same as last one, go from scratch, design up all the circuitry and build the thing. It's not easy to get 5 volts DC at 100 amps and then control it all. To start, got a microwave oven transformer. This is from a 1.2 kilowatt microwave oven, and pulled off all of the secondary winding, leaving intact the 110 volt input, and in the space where the secondary was, I put on 8 turns of a number 6 gauge wire. And when you measure that, you get roughly 5 volts AC coming out that can handle easily 150 amps. So that's the main source of the supply power, and that's located inside the box here. And to rectify that, we use a high current diode, 4 of them in a bridge configuration, and these are good for about 120 amps each, and there's 2 of them going into the positive terminal and 2 of them coming off of the negative terminal. And all the control circuitry is the same as the previous version. There's op amps measuring voltage across a sense resistor and controlling a high power transistor to control the current going to the laser head. Just everything's a little bit bigger this time. The transistor I'm using is an ISO top package. It can handle about 120 amps, 150 watts, and the sense resistor is in the same sort of package. And the problem with this is every one of these components generates a lot of heat. The diodes are putting out about 30 watts of heat each, and the transistor is putting out about 100 watts of heat, and the sense resistor is putting out about 50 watts of heat. Furthermore, the diodes are sitting at voltage, so I decided to mount each of the sections on a piece of copper plate. It's 2" by 1/8 copper bar that's 4 inches long. So there's the 2 diodes coming regulating the transformer on the negative side and on the positive side, making the 4 for the bridge. And on the back of the plate I've put in a water cooling loop that goes around, and I'm basically pumping water through a manifold at the end independently to each of the different plates. So the first plate is the 2 diodes on the negative side of the bridge and then the positive side of the bridge, each with cooling. The next plate over is the power transistor. It generates probably the most amount of heat of anything here. And then the last and 4th plate is the sense resistor. So the power comes out of the big transformer in the box, comes up, gets rectified. There's a large capacitor and resistor to filter that, and then that goes into the transistor through the sense resistor and then off to the laser head. So I built all this, tried out all the circuitry, and to start put in a load with just a couple of diodes back to back, so it's dropping about the same voltage and can handle the same current as the laser head. So rather than hurt a laser head when I'm not sure how things are going to work, I put it into the diodes and made sure that everything controlled the circuitry, made sure on the turn on and turn off that there's no spikes, overshoot or undershoot. All that was working very well. So then I went ahead and attached the wires onto the laser. There's also a couple of sense wires going back to the circuitry, and then on the bottom of the laser head is another manifold with the cooling water going through, because the laser itself, you need to dissipate close to 100 watts of heat in that location. On the control panel there's the main supply, and that powers up the circuit board with all of the electronics, the op amp, the voltage regulators, and the displays. I have a temperature measuring circuitry on one side, and I can measure independently the temperature of each of the different plates and the laser head and also the transformer inside. Right now the transistor is running at about 25 degrees Celsius. And then the second side of the circuitry is to power up the mains in going to the laser head. And there's relays in to do short circuit protection. So when you first flip it on, you make sure the power is down. And there's a pause as the relay kicks in after all the voltages get stable. And then it will open up so you can have power going to the head. So that's all automatic. And then for the cooling water, I'm using a off-the-shelf fountain pump in a reservoir right now, and it puts several liters a minute just recirculating. So I'll start that going, and you'll see the plate start to cool down a little bit. And then you can turn up the current. And over here I'm focusing it down to a point, and we get onto the focus point, it just immediately starts melting the ceramic. So I've been trying this out, going through various materials and trying different lens assemblies to figure out the best configuration for focusing it down. And I'll be mounting this into my CNC milling machine, the same as the lower power one, and it has the control input on the back to come off of the Mach 3 to be able to turn this on and off rapidly and control all the burning. This is all working very well up to 80 amps, and no voltage spikes, and all the temperatures seem quite reasonable. So I just have to mount this into a head that I can put on my milling machine, and I'll be off to the races.